All right, so today we're taking an extra day of review. Okay, so we kind of already went over that. We're reviewing some more from chapter 3. I've kind of changed up some of the questions, and I've reversed the order of the review section. I feel like the review section, a lot of times we're kind of like rushing towards the end of class, and I want to spend a decent amount of time today on this review section, especially in solving equations and solving for y. All right, so the first thing we're going to do is we're going to translate and rotate two ordered pairs. So go ahead and do that. Okay, so to translate 4 units right and 3 units down, everybody with me, do I add 4 or subtract 4? Add 4 to x, and do I add or subtract from y? I subtract from y. So that's how we got 7 plus 4 is 11. Negative 4 minus 3 is negative 7. All right, now, you're not going to be given the code to rotate 180 degrees, okay? But we know 180 degrees means to do the what? Opposite of both x and y. So everybody together, what's my new ordered pair? Negative 6, negative 6, okay? All right, next slide. We're going to solve 2 equations now. Please notice there's something, about that first one. Okay, yep. All right, so take care of that and then finish solving these equations. All right, we must combine like terms first, okay, on the same side of the equation. All right, so first week of school, one of the comments Ms. Keck made to me was, these kids don't understand how we combine like terms on one side of the equation. And I said, I taught them that. Okay, so I promise you, first week of Algebra 1, 9th grade, you're going to see these types of equations. So negative 3x plus 6x is what? 3x. Yes. Plus 12 equals 27. Where does my heart go? 3x. Okay. Then what do I do next? Y'all tell me. Come on. Let's talk about it. Yes. Minus 12 both sides. 3x equals 15. Divide both sides by 3. X equals 5. Okay. Rome, why don't you go ahead and stand up for me? Okay. All right. So next one. Negative 4 times x is negative 4x plus 16. So we saw a lot of mistakes with that second distributive. Okay, did you guys get that? All right, plus 16 equals 32. All right, check your work. Yes. 2 negatives, even number of negatives. Okay, so negative 4x equals 16. Divide both sides by negative 4. X equals negative 4. All right, did you guys get it? Did you guys get it? Okay, now, today is the day. Okay? Today is the day that you figure out once and for all how to solve for y. Okay? We're going to figure it out right now. We got to get everybody to 100%. Okay? So go ahead and solve these 2 equations for y. Solve them for y. So I need to solve for y. So that means my heart goes around the 3y. How do I move 4x to the other side? Subtract it. But can I subtract 24 minus 4x? No. So I have 3y equals, what do I bring down next? Negative 4x plus 24. Why was it plus 24? Because 24 was positive in the original problem. Now one more step across the whole equation. Divide by what's connected to y. Divide by 3. All right, so y equals negative 4/3 x plus 8. Plus 8. Okay? What I'm hoping is you guys are going to start seeing these problems. You're going to say, oh, I got this. Okay. This one is an easy one, quote unquote. Okay. All right. Next one. This one's a little goofy because the y comes after the equal sign. Okay. I would suggest, just like Hope did up on the screen, to rewrite this. 10 plus 2y equals 2x. So the y comes first. It's just easier to read. I would highly suggest that you do that on your test Friday. Okay? Where does my heart go? 2y. Come on, guys. All right, what do I do next? Minus 10, both sides. Okay? Yep, I got to get that 10 to cancel. 2y equals 2x minus 10. Now, what do I do across the whole equation? Divide by 2. Divide by 2. Divide by 2. Y equals x minus 5. If you said 1x minus 5, is that okay? Okay? Get this right, guys. You got to get this right on Friday. All right, guess what? We're going to review it again tomorrow, and I want 100% accuracy.
So on Friday, the whole test won't be on this?
No, on Friday, I just reversed the review section because it's always crammed in at the end. And we don't really get to really do those problems. Okay, so now we're getting into our chapter 3 content. Okay, so first off, we're going to start off with some vocabulary terms and definitions. Okay, first question. Okay, I need you to answer first question. It says, in order for triangles to be similar, how many angles must be congruent? Okay, I want you to answer each one of these. All right, we can number them 1, 2, 3, 4, and 5. All right, shh. Okay. All right, let's go ahead and answer these 5 questions. All right, in order for triangles to be similar, how many angles have to be congruent? Tell me, come on. All of them, all 3. Okay, some of the angles of a pentagon, 540 degrees. Guys, I could throw out any figure, any polygon. If I said hexagon, if I said heptagon, octagon, okay, you've got to know them all. You don't know which one is going to be on your test. They're all not going to be on your test, but you don't know which one. Adjacent, supplementary, what do they add up to? 180. Regular polygon. Congruent. All the angles and sides are congruent. 7-sided. Heptagon. And what is the sum? 900. Did anybody have that memorized? Did anybody have 900 memorized? Did anybody? Guys, quiet. What is my formula if I don't know it, Jada? N minus 2 times 180. So if you didn't know, you could plug in the 7 for N, subtract 2, and multiply by 180, and it would give you 900.
I thought you can do 7 times 90.
No. Okay, it's N minus 2 times 180. All right, so now let's talk angle relationships. Now, these are different angles than what I gave you guys yesterday. So what is the relationship between the angles? You will not have a word bank, okay? On Friday, you have to remember them. So what are my angle relationships? Tell me. Adjacent, vertical, corresponding, alternate. Yes, alternate interior, alternate exterior. All right, go ahead and fill these in. Numbers 1, 2, 3, 4, and 5. 1 and 3. What do you notice about their location to each other? They're next door neighbors. They share the common side. That's adjacent. Okay, what about 4 and 7?
4 and 7, they're inside.
They're inside the parallel lines, and they cross over the transversal. So that makes them Alternate interior. Alternate interior. All right, 7 and 8. What do you notice about their location with each other?
They're native.
Okay, they're across, so that means they're vertical. Okay, what about 5 and 6? They are also vertical. All right, what about 1 and 6?
Alternate
Okay,
exterior.
again, they relate, exactly, they relate to the parallel lines. One is outside, and then the other one is on the other side of the transversal, outside the parallel lines. That means alternate exterior. Alternate exterior. Angle relationships. Okay? So now we have to use the angle relationships to find the measurements. What do we know about the measurements of vertical angles? What do we know about their measurements? They are the same. They're the same. Vertical angles have the same measurement. What do we know about corresponding angles? They have the same measurement. What do we know about alternate interior angles?
They're inside.
They have the same measurement. What do we know about alternate exterior angles? Give you one guess. They have the same measurement. The only one that doesn't is adjacent. The adjacent supplementary, what do they add up to?
180.
180, okay? So your Y is to tell me the angle relationship that helped you figure out the measurement. The first blank is going to be the angle measurement. The second blank tells me how you figured it out. What angle relationship did you use to figure out that angle measurement? Okay? All right, let's go. Come on, stop drawing, stop doodling.
I got the answers.
Okay, thank you. I see some answers coming up. All right, let's get to work. Okay, so angle 2, guys, this is the one you cannot afford to get wrong. What is the measurement of angle 2? 75. Why? It's vertical. Guys, there's no math to do. All you have to do is recognize 2 is straight across from 75. So it's vertical and their angle measures are equal. All right, what about angle 4? What about angle 4? Okay, this is the one that you have to subtract from 180 because they're next door. They're neighbors. Okay, so they're adjacent. All right, what about angle 6? What about angle 6? So we said what? It's 75 degrees. And some people said because it corresponds with 2. All right, with angle 2. Or it is alternate exterior to the given angle measure. Either reason is correct. Either reason is acceptable. All right, what about number 7 or angle 7?
175.
It is also 75, and why, guys?
It corresponds to the given measurement.
It corresponds with the given angle.
Interruption, but there is no football practice today, tomorrow.
Okay, with the given
No football practice
75
today or
degrees.
tomorrow.
Middle school is still playing football?
No.
All right. So, okay, very good. All right, now, last problem for today. Find the interior angle measures of the triangle. Okay? Find the interior angle measures of the triangle. That means all 3 angles. You have to tell me all 3 of them. Okay? So let's go ahead and solve this one. Find the interior angle measures of this triangle.
Isn't a triangle?
Yeah. All right. So what do we add together? Y'all help me out. 58 plus x minus 15. What does it all equal?
2x minus 15.
It all equals 180. Okay? So now you must combine like terms. X plus x is 2x. Now, did you guys remember to subtract because it's on one side? So what's 58 minus 15? All right, 43 plus 43 equals 180. All right, now we just solve it. Heart the 2x minus 43. Aw, did it erase it? Minus 43. 2x equals 137. Divide both sides, and what do you guys get? 68.5 degrees. This is not your answer. This is not your answer. What do you need to do now? Plug it back in. So 58, 68.5, but then, yes, what do I have to do? I got a minus 15, 53.5. Okay? All right, and that's going to wrap it up for part 1 of your review.
Wait, never mind.